When working with clouds, one of the first things you discover is how to create servers, and from there on you discover how to create clusters like EKS cluster or GKE cluster or AKS cluster, and from there on you progress to autoscaling. You learn how to scale the nodes of your clusters so that they can manage the workload in an optimum way. At one moment you might need more servers, and then at another you might need less. So your cluster is expanding and contracting. And when using Kubernetes, we do that through cluster autoscalers. If you're using EKS or AKS or GKE cluster, you're likely using the autoscaler that is baked in, with the exception of EKS, which I believe still does not come with the cluster autoscaler unless you use Fargate, but that would be a different story. Those cluster autoscalers might be working better or worse. They might be scaling your clusters by adding additional nodes, or they might be manipulating autoscaling groups or node pools and so on and so forth. So some are better than others, but what they all have in common is that none of them are cost aware. They do not take into account that you want not only to scale your cluster and to have the optimum number of nodes and optimum sizes of nodes, but also that those nodes should be cost effective. If you could accomplish the same thing with cheaper nodes, then why would you scale your cluster with the more expensive nodes? It doesn't make sense. So being cost aware is not something baked into the providers, but fortunately we have third-party solutions, and today we are going to explore Cast and see how it can help us to scale our clusters, not only to accommodate the workloads that we have inside of those clusters, but also to make it cost effective. Because after all, who doesn't want to save money and have smaller bill to pay? So let's start from the beginning. Let's see how we can connect our cluster to Cast and see what we'll get from there. Once we open Cast AI in a browser, we log in, register, and do whatever we need to get there, we are faced with two possible choices. We can connect an existing cluster, or we can create a completely new cluster using the service. Now, I will not be creating a new cluster with Cast AI. It has some advantages doing that, but then I would have to have a long conversation of whether you should be creating clusters like that, or you should be using infrastructure as code tools like Pulumi or Terraform, or you should switch to crossplane altogether. So I will not create a new cluster with Cast AI. I wouldn't recommend you do it either, because I do not like creating stuff by clicking buttons. You should define what you want and store it in Git and all those things. So I will choose the option to connect an existing cluster to Cast AI. I already have a cluster, so that should be a no-brainer. So let's see what we'll get. And it's extremely simple. You have to choose the provider, whether it should be EKS or GKE or COPS or AKS. And once we choose the provider, we just copy the command and paste it into a terminal. And once I executed that command from a terminal, and if I go back to the browser, I can see that it is waiting for a new EKS cluster connection. This can take a couple of moments, and sometimes it refreshes itself, sometimes it doesn't. So if you wait for half a minute or something like that and you see that it is still waiting, you might want to click on the clusters icon in the left menu, and then you will see it up and running over there. It's a small annoyance that it is not always refreshing it correctly over here. The next thing you want to do is go straight into available savings. I want to see immediately how much I can save, and to get the full feature set, to enable the full benefit of Cast AI, you probably want to click that button that says Enable Cast AI. So that's what I'm going to do. And that presents me with yet another command, because the previous one established the connection between my cluster and Cast AI, and this one will enable Cast AI to take part of the control of my cluster and start doing funky things, which you're going to see in a second. So I'm going to copy the command, and then I'm going to go back to my terminal and paste it over there, execute that command. That should be all I need to do to establish the connection between Cast AI and my cluster, and to enable it to do whatever it needs to do, and you will see soon what it does. Okay, and once it's done, you will see the message that says start optimizing your cluster. So let's optimize it. Let's see what we'll get. Actually, we will not see right away what we'll get because there are a couple of other options that we need to choose. To begin with, we should select whether we want full cluster autoscaler or scoped autoscaler. The choice is whether we want to let Cast AI to take full control of the scaling capabilities of our cluster, or to have it scoped only to a fraction of what we are doing, right? I will go with full cluster autoscaler because I trust Cast AI and I hope that it will do the right thing. So let's see what it can do when it takes full control of my cluster. Actually, it will not take full control. That's misleading. It will take full control of the scaling of my cluster. Next, there are a couple of options we can choose from, and they're all enabled by default once you select the full feature set. And the first one is about limits, or to be more precise, CPU policy. What is the minimum number of cores that we want to use and what is the maximum? I will leave that intact and move to the next set of choices. Next, we can choose which type of autoscaler we want, whether it should be cost efficient, meaning that the cost is the primary motivation for scaling the cluster one way or another. On the other hand, it could be least interrupted, meaning that the cost is not the main motivator, but the quality of the nodes that we are using, and then there is balanced in the middle. I will leave the default option, which means cost efficient, right? I'm more concerned about money than about having uninterrupted service. Most of you will probably choose balance because you want the balance between how much money you spend and what is the interruption, what is the quality of the servers that you're using. We can have spot fallback. What that means is that the nodes that are running as spot instances will be moved to on-demand nodes if there is a problem or issue with spot instances. And you know, spot instances are not as reliable as on-demand instances. They're cheaper, and this is a great option because I can still use spot instances, and if something goes wrong with them, I can fall back automatically to on-demand nodes, which is absolutely amazing. Then there is unscheduled pod policy, which I will also leave intact. You can go through it yourself. In a nutshell, it is a set of policies that define how your cluster will scale depending on how many nodes you have unscheduled and when it should scale and so on and so forth. And finally, the last one, and the equally important one, is node deletion policy, which in an essence say, hey, if there is nothing running on a node, that node should be removed because we're wasting money, we're wasting capacity of our clusters on something that is not used at all. Later on, we are going to see rebalancing, because this is one of the problems in autoscalers in general, that they're not really good at reshuffling pods across the nodes so that we have empty nodes that we can remove, but we'll get there later. Next, we have dashboard with typical things like CPU utilization, memory utilization, and so on and so forth. I haven't been running cluster long enough, so there is not much going on here right now, but you can imagine that this shows you the graph of the utilization of different resources like CPU, memory, and so on and so forth. The key page in this dashboard is actually savings. That's where you're going to spend most of your time. So let's see what we'll get there. And at the very beginning, it looks great. My cluster seems to be running in an optimum state. There is nothing for me to do, which is brilliant. I mean, not so good for Cast AI, but good for me because that means that my cluster is working just as it should be. There is nothing for Cast AI to do. Now, spot instances are an interesting thing. And if you take a look at the workloads to run on Spot, you can see that 0 workloads or 0 pods can run on Spot instances. And the reason why nothing can run on Spot instances is because I did not yet tell my system which applications, which pods can run on Spot instances, and that's something I need to change right away. I will change it actually in a second, but let me see what else do we have here apart from Spot instances. Cluster schedule is potentially a great option over there. It allows us to schedule when the cluster should and when the cluster should not be running, which if you're running global operations and you have your users and your developers and everybody working 24/7 across the globe, then this is not very interesting. But if you know that there are certain hours of the day or days of the week, like weekends, when you're not using your clusters, then this is a great option. You can schedule when it should and when it shouldn't be running. A typical example might not be production, but let's say development or staging or integration clusters. If you're not working over the weekend, you shouldn't be running those clusters. You should shut them down or decrease the number of nodes of those clusters. And then when Monday comes, you put it back up and you start paying because you're using those clusters. So scheduling option is absolutely amazing, and you just need to figure out which clusters should be working 24/7 and which clusters should be shut down, or to be more precise, which clusters should have worker nodes shut down during specific time of the day or week or days and so on and so forth. Now I will not use that option for this cluster, so let me shut it down. Now let's see what I can do with my application to enable it to run on Spot instances. This cluster already runs a couple of things like Prometheus and Crossplane and so on and so forth, but I want to work on this application called DevOps Toolkit. So I will make a couple of changes, and those changes will follow the Kubernetes pattern. Cast AI is not reinventing the wheel here. It is using the methods that are adopted in Kubernetes and just extends them to a different level, right? So I will define node selector and say that node selector should use the label scheduling cast AI/spot and set it to true. So I'm telling Kubernetes that there is a node selector, and that node selector happens to be cast AI. And I will also define the tolerations and say, hey, this is the key, which is cast AI spot instances key, and the operator exists. And that's about it. From now on, this application should be running on spot instances and not necessarily even fully on spot instances. Cast AI will make sure that it is mixed between spot instances and on-demand instances so that we have good performance while still keeping the costs low. And the last thing I'm going to do is change the number of replicas from 1 to 20. I want to increase the workload and see not only whether Cast AI will move my application to spot instances, but whether it will increase the number of nodes of my cluster correctly so that it can accommodate the increase in the workload. And now all that's left is to apply the changes I just made to the manifest and wait for a couple of seconds until Cast AI discovered what I did and does something. So let's fast forward a minute or two and then see what happened with Cast AI. Actually, I'm not patient enough to wait until something happens. Let me go straight to the dashboard and see the nodes. Let's see what's happening with the nodes of my cluster. Now, the bottom three are the nodes that I had in the cluster from the very beginning. The top two are the nodes that were created by Cast AI. It noticed that there are unscheduled pods, and they're unscheduled because they cannot fit into the existing cluster because I just increased the number of replicas to 20, and then it increased the size of the cluster, and it did that by creating new nodes. It created two new nodes. One is on demand and one other one is spot. And it figured out the correct sizes of those nodes. Those are not just new nodes that are the same as other nodes. They're sized just right so that all the things that I need to run are now running and not more than that, right? Typically what happens is that either you get small nodes that cannot handle all the workload, and then you need to wait for the next iteration of the cluster autoscaler, and that means losing a lot of time and waiting for too long, or cluster autoscaler typically would create a huge node that would be half empty, but Cast AI is doing the right thing. It figured out what is the exact optimum size of the nodes and how many nodes it should have, and making all that cost effective and still being able to run the workload according to the specifications that I set. Cast AI reminds me a lot on Carpenter. And if you're not familiar with Carpenter, there's the video over there. You can watch it. The link to the video is in the description, but don't watch it right away. Just memorize that you should watch that video if you're not familiar with it, and now continue watching what I'm showing you right now. And what I'm trying to say is that Cast AI reminds me a lot on Carpenter, with a few very important differences. Or to begin with, similarities is that Cast AI and Carpenter are both going to increase the size of the cluster to be exactly what we need, and not with random sizes of nodes and so on and so forth. They're both aware of what pending workloads needs. So those are the similarities. The differences is that to begin with, we have a UI here. Carpenter does not have a UI, and that Carpenter is making better choices because it is not only trying to figure out how to run all the workload, how to increase or decrease the cluster with all the workload, but also how to make it cost effective, how to make sure that we have everything we need while still not spending more money than we should spend. And on top of that, Cast AI is much easier to configure than Carpenter, so that's additional advantage. And when I say easier, I mean that Cast AI is figuring out things while Carpenter expects us to specify, hey, those are the types we need, those are the types we don't know, this is the list of the types, so the sizes of the nodes and so on and so forth. So it's easier, it is cost effective, and there is a third very, very important difference. Cast AI works on Google Cloud, Azure, and AWS, while Carpenter today is limited only to AWS. So if you're thinking better to use Cast AI or Carpenter, I'm telling you right away, Cast AI is a better choice. AWS is creating the nodes that will take a couple of minutes. And by the way, this is happening much faster than if we used autoscaling glue groups or any other type of node pools and so on and so forth, because node pools, autoscaling groups and so on and so forth are very slow. They need time until they discover that they need to do something. In case of Cast AI, the scaling happened almost immediately, and that's precisely what we need. We do not need until some external entities figure out and spend minutes just trying to figure out what to do. This is happening immediately because, among other things, Cast AI is not using node groups. Node groups are not good for cluster autoscalers. Now, if I go back to the dashboard, I can see that I still have only 3 nodes, the initial 3 nodes, and I have 16 unscheduled nodes. Now, I do have to wait for a while, so let me fast forward until there are no unscheduled nodes and see what will happen. There we are, I'm back after a minute or 2 or 3, I'm not sure how much time passed, and now there are no unscheduled pods. I have 5 nodes in my cluster, 3 initial nodes, 2 nodes created by Cast AI. 2 of those nodes, the new nodes, are spot instances and they're managed by Cast AI, while the original 3 nodes are still managed by EKS itself. Now there is another interesting thing here. We can see that allocatable CPU is 97%, even though requested CPU is 62%. That's my mistake because I did not really define requests and limits well. So there is a discrepancy, but that's on my side. That's because I didn't define the application well. And the reason why I'm telling you all that is that we can easily see here those discrepancies and potentially improve our applications as well. Now let's go to available savings. And you can see that green line over there that says, hey, my cluster is running in optimum capacity. There is nothing for me to do. Cast AI did everything that needs to be done. And that's about it. It's as easy as that. And the only thing left for me to show is the rebalance option. You can click that rebalance button and then you get a plan of what Cast AI should do to rebalance your pods. What that really means is that over time some pods are removed from some nodes and some are added to other nodes, and then you have a mishmash of many nodes that have suboptimal utilization. If we rebalance those pods, we might end up with empty nodes and full nodes so that Cast AI can remove those nodes. So I can generate the plan and then Cast AI will tell me whether rebalancing would be beneficial for me. In this case, there is nothing to rebalance because I haven't used this cluster sufficiently long, but if I did, after a couple of new deployments and new releases and so on and so forth, rebalancing would likely result in a reduction of the number of nodes because Cast AI would move some pods from one node to another and so on and so forth and end up with empty nodes that could be removed. And by rebalancing the pods and removing the nodes we don't use, we save money. And I like saving money. So, what do I think about Cast AI? To begin with, I should compare it with Carpenter because I think that Carpenter is closest to what we have to Cast AI, but Cast AI has some obvious benefits. To begin with, we have a visual representation of what's going on. We have an easy way to configure it, much easier than with Carpenter, and most importantly, it is more efficient and it is focused not only on blindly scaling the cluster to accommodate the workload, but also to make it cost effective. And I like that idea a lot. I think it makes a lot of sense to scale your cluster, not only according to the rules that are required to accumulate the workload, but also to make it cost effective. So the idea is absolutely brilliant. It's simple, easy to use. I like it. So the pros are very straightforward. It's simple and it is effective. And those are the advantages we are really looking for. Now the disadvantages or cons or the things I do not like completely, that I'm not 100% agreeing with, is, to begin with, I do not like the idea that Cast AI should be creating a cluster for me. We already have the tools for that. I'm most likely not going to switch from EKS Cattle or Terraform or Pulumi or Crossplane to Cast AI for managing, for creating a cluster. There are tools that do that work very, very well. And I think that Cast AI should focus completely on scaling and making that cost effective, making it cheaper for me to run my cluster. That should be the focus, not really creating clusters. Another thing that I think could be improved. So think of this as lost opportunity or missing opportunity rather than a negative comment. And that is more granular cost. It would be great if I could somehow associate those prices, those costs per namespace, maybe, or type of workload, so on and so forth, so that I can see not only how much I can save on the cluster as a whole, but also what is happening within the cluster. Which team in my company is using most resources? Who is spending the most money? So maybe more granular cost report would be a good idea. Again, it's not a negative thing, it's more like a missed opportunity, right? Split the costs across namespaces, types of workloads, and so on and so forth. And the third thing that I believe is missing, and that's a connection with the tools that enable us to define things as code. It would be great if Web UI would have two modes, like, hey, do it now, enable this thing right away, or here's a Helm chart, or Kubernetes YAML, or Customize, or Terraform Pulumi, or anything. Here are the things that you can store in Git and then run it from there, so that you can track which changes were made in Git instead of Web UI. All those negative things are minor. They're either missed opportunities or not that important. What does matter is that Cast AI is doing what it's supposed to be doing. It is very good at scaling, and it is very good at making scaling cost effective. So, big thumbs up. Use Cast AI. It will save you money, and it does a very good job at doing that.